Please like, share and subscribe my YouTube channel, YT Abdul Aleem.
Hello friends. I hope you're all doing well. In this video, I'll explain what a counter is and the different types of counters. So let's get started. Types of relays. Relays are essential components in electrical and electronic systems, serving as electrically operated switches to control circuits. They come in various types, each tailored for specific applications. Here's an overview of the most common types of relays and their uses. 1. Electromagnetic, mechanical, relays. Description: traditional relays that use an electromagnet to open or close contacts. Applications: widely used in automotive, industrial, and household applications for switching high-power circuits. In this diagram you can understand relay. 2. Solid-state relays, SSRs. Description: use semiconductor components like thyristors or phototransistors to perform switching without moving parts. Applications: ideal for precise control, silent operation, and environments requiring high reliability, such as industrial automation and temperature control systems. In this picture you can understand relay. 3. Reed relays. Description: consist of reed switches enclosed in a glass tube, controlled by a magnetic field. Applications: suitable for low-power applications like test instruments, small switching devices, and communication equipment. In this picture you can understand relay. In this diagram you can understand relay. 4. Thermal relays. Description: use the principle of thermal expansion, typically employing a bimetallic strip that bends when heated, to interrupt the circuit. Applications: commonly used for motor overload protection, safeguarding motors, transformers, and other devices from excessive heat due to overloads. In this picture and diagram you can understand relay. 5. Time delay relays. Description: introduce a delay before switching contacts. Applications: used in applications requiring controlled timing, such as motor start-up sequences, lighting control systems, and HVAC systems. In this picture you can understand relay. 6. Latching relays. Description: maintain their position, set or reset, even after power is removed. Applications: ideal for applications like controlling a light from multiple switches, as they retain their state without continuous power. In this diagram you can understand relay. In this picture you can understand relay. 7. Safety relays. Description: implement protection functions to reduce risks to an acceptable level in hazardous situations. Applications: essential in machinery safety systems, emergency stop circuits, and safety interlocks to ensure operator safety. In this picture you can understand relay. 8. Overvoltage relays. Description: monitor voltage levels and activate when the voltage exceeds a preset threshold. Applications: protect circuits from overvoltage damage, commonly used in power systems and equipment protection. In this picture you can understand relay. 9. Liquid level relays. Description: monitor and control the height of liquids in containers. Applications: used in managing liquid levels in water tanks, pools, and oil reservoirs to prevent overflow or dry running. In this picture you can understand relay. In this diagram you can understand relay. 10. Frequency relays. Description: monitor the frequency of an electrical system and activate when it detects a frequency outside a specified range. Applications: play a significant role in power generation and distribution networks to protect against damage caused by abnormal frequency fluctuations. In this picture you can understand relay. 11 Hybrid relays. Description: combine the benefits of electromagnetic and solid-state relays, offering a balance between reliability and performance. Applications: used in applications requiring both high switching capacity and fast response times. In this picture you can understand relay. In this diagram you can understand relay. 12 Potted relays. Description: sealed with materials like thermosetting plastics or silicone rubber to protect against environmental factors such as dust, moisture, shock, and vibration. Applications: ideal for marine, industrial, and other demanding applications where reliability is critical. In this picture you can understand relay.
Thanks for watching.